Yanis. Yanis is a research manager at the Latvia State Forest Research Institute. He has a master's degree from the University of Latvia, in which he has did some work related with developing a methodology for mapping overgrown vegetation based on remote sensing data. He's now currently studying in a doctoral program at the University of Tartu and developing models for estimation of forest biomass volume based on remote sensing data and in the territory of Latvia. Yanis, the screen is yours.
Hello, can you hear me well?
Yes, very well.
Okay, thank you. So I will try to be brief with my presentation. And topic will be about automation in forest operations, and I will touch subjects such as remote sensing, what can we detect and how can we use the applications we have developed, and also I will touch a little bit what we have done in ground level and what operations we have developed in rot detection. Yes, today we will explore advancements in forestry management through the lens of automation. I will share you with some maps which we have developed in Latvian State Forest Research Institute Silava. And most work that we are doing right now relates to predictive analytics and machine learning algorithms that we use to predict different forestry variables across the country. And in this example, you can see one of sample plots from NFI dataset that we can widely use as ground truth data for teaching algorithms. Yes, and using NFI data and different remote sensing imagery and ALS data, for example, LiDAR data, we can create, for example, forest tree species distribution maps across Latvia, for example, and then use information from tree species map to precisely predict different forest variables such as forest height, forest biomass, and etc. And we have created species-specific models to more precisely estimate those variables. And in this image you can see this classification of different tree species map according to color scheme used in Latvia. So in this case, most dominant tree species is Scots pine, and also there is some Norway spruce, birch, alders, and aspen. We can also predict different variables that are not related directly to the forest and trees. And in this case, we have created maps for wet areas in forest landscape and also tried to predict peat depth in each and every pixel across the country. Those kind of maps you can use in forestry applications in many different ways. Most popular could be probably to try to avoid disturbances in soil. So if forestry machine operators can visually see the maps of the area where they will be operating, they can already see most vulnerable areas that they need to be very careful to drive on. So in this case, we can try to protect forest soil and from many different disturbances. And also we can use those peat depth maps to calculate carbon stocks across the country that are stored in soil. And then another topic that we developed in forest applications was automatic rut detection in forwarding operations in forest. So basically we mounted different sensors on top of forwarders and developed algorithms to try to measure ruts that are left behind forest machinery. In first case, we put LiDAR sensor on top of forwarder, and when forwarder is driving in and out in the forest, we measured distance to the ground and surrounding areas to probably detect those ruts that are deeper than 20 centimeters. It worked very well in areas which were not where forest roads were not covered by tree branches, but when the branches were put on driving roads, then this made some disturbances in the data. So in next step, we put simple GNSS sensor on top of forwarder. You can see this little black box on top of forwarder here. So we measured GNSS coordinates precisely in everyday work of forwarder operator. And when forwarder operator drives in and out of forest, first riding in, we detect what is height of forest ground, and subsequent travels on the same path shows us subsequent heights of this forwarding machinery. And if this height is reducing, we can measure this difference between original surface of the ground and subsequent travels. And if this difference is more than 20 centimeters, then we can check that there is already roots forming in the forest. So yes, as I showed you briefly about some automation in forestry, we could benefit in many different ways, and most popular maybe benefits could be efficiency, sustainability, and conservation in the forest. We can automatically detect many different things which are related to the forest trees and tree species. We can detect forest height, forest biomass, and many different other aspects, and we don't have to use extensive manual labor to go to the forest and measure all those aspects of forest. So we can already try to detect it from the maps. Then we also can optimize resource management by not sending people to the forest. And also about conservation efforts, that automation facilitates accurate monitoring of forest conditions, leading to improved conservation efforts and also biodiversity preservation. Yes, and as main conclusions would be that automation is revolutionizing forestry management by harnessing the power of remote sensing and different technologies. And through automation, we can achieve greater efficiency, sustainability, and conservation in forest operations. And that's it from me.
Thank you, Janis.